Alrighty, here are some practice problems to help you as you work through the problem set for the week. And this week's problems are from chapter 6, number 36, 47, 54, 77, 78, and 85. Our learning objective with these practice problems is by the end to be able to say, I can calculate heat and enthalpy changes using heat capacities and standard heats of formation. The first practice problem we're going to work through is number 38, and it reads as follows. A 27.7 gram sample of ethylene glycol, a car radiator coolant, loses 688 joules of heat. What was the initial temperature of the ethylene glycol if the final temperature is 32.5 degrees Celsius? C, or the specific heat of ethylene glycol, is 2.42 joules per gram times Kelvin. Our first step should be to figure out what it is that we're looking for. Hopefully you've already decided that it is the initial temperature, the T initial. And let's also look at what information we do have. We've got the mass, which is 27.7 grams. We've got our Q, or our heat. And I highlighted the minus sign because in our question, if we look at the words, it doesn't have a minus sign here, but it says it loses 688 joules of heat. So that means the ethylene glycol is going through, or is it's exothermic. It's giving off 688 joules of heat. We also know the specific heat of glycol, which is 2.42 joules per gram times Kelvin. And we know the final temperature of 32.5 degrees Celsius. So hopefully by now you've decided what formula we should be looking at. And yes, it is Q equals MC delta T. Delta T, of course, meaning the final temperature minus the initial temperature. And I've got that spelled out because I think it helps to make it a little bit more clear with our thinking as we work through this problem. So with all of that information in mind, how are we going to work through this? Personally, I am going to rearrange this first before I plug in numbers, just so it stays a little tidier. And the first thing I'm going to do to rearrange this so that I can isolate my T initial is going to be to divide both sides by MC. So I'm going to get Q over MC is equal to T final minus T initial, just like that. The next thing I'm going to do is I'm going to move this T final over to this side of the equals sign. So that it looks something like this. So I now have Q divided by MC minus T final is equal to the opposite of T initial. Now, I know myself, I could work through this problem, but if I leave it as is, I'm going to forget to change that sign. So I'm going to multiply everything by -1 to get not the opposite of T initial, but to get T initial on its own right now. And when I multiply everything by -1, this T final becomes a positive, and this Q divided by MC becomes negative, which is why I've got T final minus Q over MC equals T initial. Now I'm at a point where I can start plugging in numbers, doing the math, and I'll get my answer. So I have my T initial equals 32.5, the T final, minus the opposite of, or minus 688, which is our Q, divided by, for some reason I've switched around my C and M. I've got my 242 times 27.7 grams. Let's simplify this fraction down a little bit because it's a bit bulky. We've got 32.5 minus 688 divided by 67.3 when we multiply 2.42 and 27.7. And that's going to give us 32.5 minus negative 10.26, which is the same thing as 32.5 plus 10.26. So our answer is going to be 42.8 when we do some rounding. And that is our initial temperature. We're going to move on and do one more practice problem. We're going to do number 80, which reads, as acetylene burns in air according to the following equation. Acetylene gas plus 5/2 diatomic oxygen gas yields 2 carbon dioxide gases plus 1 water vapor, because water is the gas. The heat of reaction for that is negative 1255.8 kilojoules. Given that the heat of formation of carbon dioxide gas is negative 393.5 kilojoules per mole, and the heat of formation of water vapor is negative 241.8 kilojoules per mole, find the heat of formation of acetylene gas. So here I already have our target identified, and hopefully you're already starting to figure out which formula we're going to use. Yes, it's this one. So we've got our heat of formation equals the sum of the heats of formation of the products minus the sum of the heats of formation of the reactants. The M and the N, of course, represent the coefficients that we will need to include as we work through this. For this one, I'm going to rearrange this. I'm not going to rearrange this yet. I'm going to plug in the numbers that we have or the information that we have and then rearrange it, because actually with this one, you'll see that it gets a little bit simpler due to a cancellation. So we've got 2 times our heat of formation of carbon dioxide gas, because here in our products, we've got 2 moles. We only have 1 mole of water, so we just have heat of formation of water. We'll add those 2 together, and then from that subtract the heat of formation of acetylene, which we don't know, and 5/2 times the heat of formation of oxygen gas. But you'll notice that we don't have a value for the heat of formation of oxygen gas. Hopefully you're saying, of course, Ms. Milberg, that's because the heat of formation for standard states is always 0, which is, like I said, why I'm writing this out first, because our next step when we plug in the numbers that we have, it's going to look like that, which is a heck of a lot tidier than the previous equation I've got written out. So I've got our heat of reaction, because we know that. I've got 2 times the heat of formation of carbon dioxide gas, the heat of formation of water vapor, and then here is our unknown, because our heat of formation of diatomic oxygen gas is 0. 0 times 5/2 is still going to be 0. Let's start doing some multiplication, some adding, and moving folks around. When I multiply out the 2 times negative 393.5, then I get negative 787 minus 241.8, because I'm adding a negative there, and then minus the heat of formation of acetylene. That is going to give me, when I simplify that out even further, negative 1255.8 equals negative 1028.8 minus the heat of formation of acetylene. And so then if I move this friend over here by adding it to both sides, I'm going to get, now you can't see that because my screen's in the way. There we go. Now you're going to be able to see that the opposite, so negative, the opposite of the heat of formation of acetylene gas is equal to negative 227 kilojoules. And that's because I have not done anything. I just moved this over here, but that means I still have to mind this negative sign. So again, this is super important, minding the signs. And I'm not looking for the opposite of the heat of formation. I'm looking for the heat of formation. So I'm going to multiply both those sides by -1 and get my answer. The heat of formation for acetylene gas is 227 kilojoules. I hope that this helps. Neither of these are exactly like anything that you're doing, but they've got some very similar and very important properties that are similar to the problems that you're working on. So if you have any questions, please send me an email, and I'm happy to help you. Good luck with the problem set.